All right, so what I need you to do is make sure you fill out your warm up, your blank copy, along as we do this, because with the video, this is really, I guess, in a sense, like notes, but this is not anything new. So we're really taking some stuff that we learned earlier in the year and combining it with the 5 properties of parallelograms that you worked on last Thursday and Friday. So you'll notice that these are the same 5 properties that you used in your notes for 7.2. So this is kind of an extension. And we're going to extend those properties to parallelograms on the coordinate plane. So when you have your x and y axis and you're plotting points and you connect those points to make a parallelogram, we want to see if we can prove that it's a parallelogram on the coordinate plane. And we don't just assume things, we have to prove it. Now, I'm not talking about 2-column proofs. I'm talking about doing some mathematical, maybe calculations on that coordinate plane. So the first one says prove, if you had to prove that a parallelogram by the definition. And so you have to know that the definition of a parallelogram is that both pairs of opposite sides are parallel. So in order, and we can do that, we can totally show that on a coordinate plane. So if we want to show that opposite sides are parallel, we're going to do that by showing that the opposite sides have, and before I write this down, if you can remember, we can look at parallel lines on a coordinate plane. And we did this back in chapter 3, you did this in algebra 1, where you know that 2 lines are parallel on the coordinate plane if they have the same slope. So what you're going to have to do then is you can use that slope formula, and I'm writing this down in case you forget, which is m stands for slope, y2 minus y1 all over x2 minus x1. And remember, that's if you have a point x1, y1 and another point y1, y2. So basically, y1, y2. So you're just going to subtract the y coordinates, divide that by the subtraction of the x coordinates. So that's just your slope formula, okay? Number 2, prove that both pairs of opposite sides are congruent. Well, we can absolutely show that. To show that 2 sides are congruent, remember, we have to show that they have the same length. So we would show that opposite sides have the same length. And in order to do that, remember, we're going to pull out that distance formula that we reviewed all the way back in chapter 1. So if you have 2 endpoints, you can find the length between them. So we have x1 minus x2 squared plus y1 minus y2 squared. Remember to follow order of operations, okay? So you're adding in the middle, but you have to subtract, then square, subtract, then square, add, then the square root would be the last thing you do. For number 3, if you want to prove that opposite angles are congruent in a parallelogram, which is a property, the only way that we could do that is if opposite angles were 90. Because we can show that 2 lines are perpendicular, which means 90 on a coordinate plane, but not all parallelograms have to have 90 degrees. So this one you cannot do. So we cannot show this property on a coordinate plane. Cannot do it. Number 4, if you want to prove that consecutive angles are supplementary, meaning that the 2 angles right in a row, regardless which 2 angles in a row you're looking at, are going to add to 180, we don't have a way on a coordinate plane to show angle measures. So this property we cannot show this on the coordinate plane. And then finally, the last one, you want to show this property that you should hopefully know by now, that these diagonals are going to bisect each other. And if you can recall, we would have to show that this has the same length as this piece of the diagonal, and this part of that diagonal has the same as that one. And we can totally do this on the coordinate plane. So once again, we are going to do this by showing that both segments that make up each diagonal have the same length. And once again, we would do this by using that distance formula. And since I already reviewed that formula with you up here, I'm not going to write it again. Okay? So the idea when you are going to prove, and eventually we will get to 2-column proofs, but the goal here is if you can prove 1 out of the 5 properties at the top that we just reviewed, that shows it's a parallelogram. So let's walk through these examples so you can kind of realize it's just really the math that you need to do. But in this example, we have to prove that ABCD is a parallelogram by using the definition. And I won't always tell you this, but that definition, remember, is the property that basically both pairs of opposite sides are parallel. And I'm really guiding you more. I won't guide you as much on a test or quiz. But if I graph these points, which you don't necessarily have to do, but I think it's important to kind of visualize what we're looking at. If I graph parallelogram ABCD, we want to show that AB is parallel to DC. So I already have that kind of guided and set up for you. So basically, we're going to find the slope of this horizontal line segment, which I'm hoping you remember, but if I take the coordinates of A and B, I'm going to do the y coordinates, 3 minus 3, all over 4 minus -1. That gives me 0 over 5, which is 0. We always want to simplify that fraction. For the slope of CD, we're going to do m equals -1 minus -1, the y coordinates, all over the x coordinates, -2 minus 2. A -1 minus -1 is 0. This would be 0 over -5, which is 0. Now, since they have the same slope, so what I kind of write off here just to kind of understand in your warm-up is that since they have the same slope, what that tells us, is that AB is parallel, there's that parallel symbol, oh my goodness, sorry, to DC. So we now have proved that one pair of opposite sides are parallel. Well, the problem is we now have to prove that the other pair of opposite sides are parallel. So we now need to show that AD is parallel to BC. So as you can see in your notes, I'm really guiding you a lot, or in your warm-up, I should say. So if I find the slope of AD, we want to use A and D, so I'm going to subtract those y coordinates over the x coordinates, and that gives me -4 over -2, which is 2. Remember, these are, is a +2. Remember, these lines are rising to the right, so they should have a positive slope. And then for for BC, we want to find the slope, so we're going to look at these 2 points. So I'm going to do -1 minus 3 all over -3 minus -1. Use your calculator if you need to. And this also has a slope. It's a -4 over -2, just like we had over here, and that's +2. So once again, since these have the same slope of 2, sorry, +2, I have to fix this, that looks like a negative, it's going to drive me crazy. Since they both have the same slope of 2, that means that AD is parallel to BC. So we mathematically, with our calculations, have just proved that opposite sides of this parallelogram ABCD have the same slope. Okay? All right. Now what I'm going to have you do is I'm going to get you started on this one, and then instead of you just doing it with me, I want you to do it, and then the answer key to this warm-up is posted along with this blank document in the video, and then you can check your work. Okay? So the first thing I'm going to do is I'm just going to go ahead and make sure you have your Joy's program looks like mine. So I'm going to plot 1, 1. I'm going to plot 2, -6. And label as I go, 3, 3. A funky point, and then, ooh, 2, 10. And that's all the way up here. So if I connect these to make my parallelogram, we have this stretched out skinny looking thing. So it says, prove that Joy's is a parallelogram by showing that both pairs of opposite sides are congruent. Now, if you look back to the front, the way that you need to do this, and once again, I'm really guiding you because this is a warm-up, is we have to show two different things. So we need to show that JS is congruent to OY. And if I use a different color here, what that means is we need to show that JS has the same length as OY. And for some reason, my students want to dive in and think that we should do slope again. We're not doing slope. We want to know, like, if OY is 10, then JS is 10. So what you're going to need to do is that distance formula. So just to review, I'm going to do one part with you. So if you look at the distance of JS, we need to find the distance formula. So I'm going to subtract the x coordinates, square them, and subtract the y coordinates and square them. Now, if you do this correctly, we have the quantity of -1 squared plus the quantity of -9 squared. So by order of operations, we're going to square and get 1. We're going to square -9 and get 81. Now, there's no need to, we could possibly, simplify or this, or I really don't want you to change to a decimal, because what you now need to do is you now have to go down and find the distance of OY. And you really know what you should be getting. If we're going to prove that opposite sides are congruent, when you do the work and you start this distance formula, you should be getting square root 82 for both. Okay? Now, you're not done, because what you then have to do is you have to come down here and say, okay, we just showed that, and you need to finish your work, that the opposite sides were congruent. But we only did one pair. So now what you have to do is you have to find the length of JO and the length of SY. So that's why I gave you so much room, because now down here, we need to show that line segment SY is congruent to line segment JO. And that means you have to do the distance formula twice, one for SY, one for JO, and then they should be congruent. Because remember, it says prove. It's not saying is this quadrilateral parallelogram. It's saying prove it. So we know what we're looking for. We just have to show that math to back it up. Okay? So finish your mathematical calculations here, and then check the answer key right along where you found this blank copy in the video. Okay? All right. Good job. Thank you. Bye.